So what happens? We have impurities. Pure water, boiling point is 100 degrees Celsius. But if it is impurities, the boiling point of a liquid increases when impurities are added. So this is for pure, but it may be 100.6 degrees Celsius or greater than 100. Boiling point is greater than 100 for impure water. Impure water means addition of salt or minerals, anything. So if you have to cook well, so you can add salt while cooking pulses. Then the salt in water provides sufficient heat energy to its contents. So for quick cooking. So we add a little bit of oil also. When we cook dal, we add a little bit of oil, like few drops of oil, so that the boiling temperature increases and the pulses are cooked thoroughly faster. This can be assertion reason question. Okay, now let us move on to latent heat and specific latent heat. We studied that the curve of fusion, melting and boiling in the last calorimetry class. So how the ice cubes, you take ice cubes and start heating till all the ice cubes are melted. The thermometer does not record any increase in temperature. It stays till 0 degrees Celsius. Only when all the ice is melted, only when there is a phase change complete, then the temperature starts increasing. Similar, so that is called, so why there is heat energy applied but nothing is showing in thermometer? That is the latent heat, hidden heat. The heat energy is not expressed. So we are going to study about that in detail. So it's same with boiling also. After 100 degrees Celsius, there is no increase in temperature recorded for a while until all the water is converted to steam, and then the temperature of steam increases. So this is latent heat or hidden heat. Let us study that in detail. So during phase change, temperature remains constant even though we continue to heat. So the heat energy can be absorbed or liberated. When will it be absorbed? If we are melting melting ice cube and boiling water, heat energy is absorbed. During melting and boiling, heat is absorbed. We are continuing to heat. But on condensation and freezing, heat energy is liberated. It is liberated or given out. So can you say melting and boiling are endothermic reaction? Do you agree, Ma Vikasini?
Yeah, aunty.
Melting and boiling are endothermic reaction because heat energy is absorbed. Whereas condensation and freezing is exothermic reaction where heat energy is released. Okay. So heat energy is absorbed by a solid during melting and equal amount of heat energy is liberated by the liquid during freezing. And there won't be any change in the melting point or fusion point. So if ice is melting at 0 degrees Celsius, melting point and the fusion point, both will be 0 degrees Celsius. Same thing, boiling point and condensation. So condensation point will be same. Condensation point means the temperature at which it it condenses to water. So the temperature remains same for 0 to ice to water or water to ice. So heat energy absorbed or liberated in change of phase is not externally manifested. It is not exhibited in the thermometer. It is not shown. So that is called latent heat or hidden heat. If the latent heat is expressed per unit mass, then we call it as specific latent heat. Hello, ma'am. Nandini.
Hello. I know.
So we continued with the recap of calorimetry. So then we are continuing with latent heat. What happens for boiling point if it is impure water? Boiling point for clear water is 100 degrees Celsius. But if you have impurities like salt, water, salt, oil, minerals, then the boiling point.
I thought we finished this, right?
I don't know. I did not note it in the notebook, so I repeated it.
Oh,
Latent
okay.
heat and specific latent heat. So latent heat. So we studied that in the during melting, the curve doesn't show the increase in temperature. We keep continuing to heat the ice cube, but we don't see any increase in the temperature, even though heat energy is supplied, and that is called the latent heat. The heat energy that is supplied but not manifested, but not expressed in the thermometer. So when you write if they ask you what is latent heat, so you have to write both heat energy absorbed or liberated. So if it is melting, it is heat energy absorbed. If it is fusion, heat energy liberated in change of phase, and it is not externally manifested by any rise or fall in temperature is called latent heat. So don't write only one, write both absorbed or liberated, rise or fall in temperature. Latent heat, when it is expressed per unit mass, is called specific latent heat. Did you study Q and Q dash last A part?
Yeah, ma'am.
Heat capacity, specific heat capacity, same thing. Latent heat, specific latent heat. When it is measured per unit mass. So latent heat is denoted by the symbol L. So L is equal to Q by M. Heat energy absorbed or released divided by mass. So if it is 3 kg, you divide by 3 kg, so you get unit mass. So specific latent heat of a phase is the quantity of heat energy absorbed or liberated by the unit mass of the substance for change in its phase at a constant temperature. Do not miss these keywords. Constant temperature. Temperature is not increasing. Absorbed or liberated. So they can give you even the definition, 4 different forms of the definition per MCQ, and ask you to choose the right one. So make sure you have the exact definition with you.
Okay.
Okay, so same thing, Q is equal to M into L. So now what is the SI unit of latent heat? Heat energy
Joule per
absorbed or
Kelvin.
joules per kilogram.
Kelvin. Oh,
So mass is kilogram. Latent, okay, this is joule. Heat energy is joule. So what is latent heat unit? So latent heat is equal to Q by M. Q is measured in joules. Mass is measured in kg. So the SI unit is joules per kg. Other units are calorie per gram, kilocalorie per kilogram. And the conversion is also important. This can be a direct MCQ. 1 kilocalorie per kilogram is equal to 1 calorie per gram. 1 calorie per gram equal to 4.2 joules per gram, or it can be 4.2 into 1000 if it is per kilogram. So which of the following is incorrect, they can ask. So make sure you spend some time on this conversion also. Okay, we are going to study about specific latent heat of fusion of ice. All these numericals are not tough. You spend some time first time when we do the numericals, you can crack any numerical with ease. Calorimetry is difficult for the first time, second and third time when you study, it becomes piece of cake. Specific latent heat of melting is the heat energy required. So if they ask specific latent heat of melting, then no need to write melting or fusion. So just write heat energy required to melt unit mass of ice at 0 degrees Celsius to water at 0 degrees Celsius. No need to worry about this now. This is not the final um, definition, because okay, I think we can take this. The energy to melt water of unit mass, like 1 gram or 1 kilogram, unit mass of ice at 0 degrees Celsius. And if it is completely melted to 0 degrees Celsius water without any change in temperature, that is specific latent heat of melting. You can take this definition. Specific latent heat of fusion is heat energy released when a unit mass of water at 0 degrees Celsius freezes to ice at 0 degrees Celsius without any change in temperature. Latent heat of, they can simply ask latent heat or specific latent heat or specific latent heat of fusion and melting separate. So watch out what is the definition and put the appropriate words. Okay. For pure substance, the specific latent heat of fusion is same as the specific latent heat of melting. Again, this can be assertion reasoning. What do they say? If it is taking, for example, 100 joules or x joules, if it is x joules per gram, is the latent heat of melting. Latent heat of melting of ice cube to water is x joules per gram, then it will be same x joules for fusion. Both will be same. Are you able to follow, Ma? Do you have any idea? Do you have any doubt?
no.
If it is a pure substance, no other substance mixed. So the specific latent heat of fusion is same as the specific latent heat of melting. So for ice, the specific latent heat of fusion is really more. So 3.36, okay, 336 into 10 power 30. 3.36 into 10 power 5 joules per kilogram. Lot of energy is needed. It absorbs this much energy when it is converted to ice. It liberates this much energy when it is melting. When it is fusion, converting, when it is frozen or melted, this much energy is either absorbed or liberated. The equivalent is 80 calories per gram. 1 gram of water at 0 degrees Celsius has 336 joule more than 1 gram of ice at 0 degrees Celsius. This can be a MCQ. So not directly, they will say why we should, like for example, during summer, if you want to keep some cool drinks during your match, sports match, why we should keep it in ice water, ice cubes rather than ice water. So for cool drinks, you can keep all the cool drink bottles, okay, cool drink bottles in 0 degrees Celsius water rather than all the cool drink bottles kept in ice cubes. So this has more cooling power. 0 degree ice cools more cooling power. So you have to express 1 gram of water at 0 degrees Celsius has 336 joules more heat than 1 gram of ice at 0 degrees Celsius. That's why we can, the ice cubes offer more cooling. So some common substances, they give specific latent heat. So water has more higher, to look at it in the chart, the last one is water. Okay, explanation of latent heat of melting on the basis of kinetic model. So what is kinetic model? According to kinetic model, molecules in a solid vibrate about their mean position. So if you take ice cube also, water molecules are present in solid form. They vibrate about their mean position. The total energy of a molecule is the sum of its kinetic energy due to motion and the potential energy due to the force of attraction. I think you studied kinetic model in another chapter also. Like you studied pendulum and the tossing of coin. Kinetic model you studied for energy lesson. So if you toss a coin or stone, it goes up, reaches a height, and then falls down. So you have total energy is equal to potential energy plus kinetic energy. This is the kinetic model. Same way, according to kinetic model, if you take an ice cube, it's made up of many molecules. So it vibrates about their mean position, even in solid form. The total energy of a molecule is the sum of kinetic energy due to motion and potential energy due to force of attraction. So kinetic energy is due to motion, and the kinetic energy increases, depends on temperature. If you heat, it starts vibrating even further. You can see in boiling water, the molecules, jump up and down. So kinetic energy is more on heating. Why? What is the reason of potential energy? It depends on force of attraction between the molecules and the separation between them. the force of attraction between the molecules and separation is potential energy, or sorry, not potential energy, yeah, potential energy. This is potential energy and the vibration is kinetic energy. So when a solid changes to liquid without any change in temperature, average kinetic energy does not change. Kinetic energy remains same. When we heat a piece of ice cube, the kinetic energy remains same because the temperature remains same. Kinetic energy depends on temperature. If the temperature is constant, then kinetic energy does not change. But separation between molecules increases. This can be another reason question. So when during melting, kinetic energy remains same because temperature is same and potential energy increases. So we have law of conservation of energy. Whenever heat energy is converted, I mean, we are supplying heat energy. So how is it expressed? Potential energy increases. What is the potential energy due to? Force of attraction between the molecules and separation between them. This kind of energy increases. Some energy is required for increasing the separation against the attractive forces, and this heat energy is utilized for that. So no heat is used in volume expansion. For volume expansion also, okay, so since the heat increase in volume is negligible, there is no increase in volume. So no heat is used in volume expansion. We have studied thermal expansion of objects in earlier classes. When you heat, the volume expands usually. So here volume is not increased on melting. So the heat energy supplied during melting is utilized only in increasing the potential energy. These are small points that they can use to confuse you. So when 1 gram of ice at 0 degrees Celsius changes to 0 degrees Celsius, 336 joules of energy is supplied, absorbed. And what is all the energy contributing to? It is contributing to increase in intermolecular separation. That's why it closely packed solid form becomes loosely packed water molecules, liquid form, using the 336 joules energy. Okay, let's quickly check this facts. All these are easy natural consequences of high specific latent heat of fusion of ice. We saw that in the table, water is at the end. Everything is, only 12.5, 37.7. This is 336 into 1000. So why is it really high and what is the effect of it? Snow on mountains does not melt all at once, thank God. Because of high specific latent heat of fusion of ice, if you see Himalayas, it's snow-peaked mountains, all snow. So it doesn't melt all at once. If it melts all at once, then we will not have this perennial rivers. We have Ganga, Yamuna, Sindhu. They are perennial rivers because if they melt all at once, then we will have flash floods. So since it is, nature has given high specific latent heat of fusion of ice, it slowly melts and we get perennial rivers and it benefits all the life forms. So snow on mountain does not melt all at once. Since it has, for every kg, this much energy is needed, so it slowly melts and we get continuous water flow. Had it been low, had it been low, then we will, in short time, it will melt and there will be flash flood. Are you able to follow, Ma? Vikasini, Nandini?
Yeah.
Okay. So it's a blessing that it has high specific heat capacity. In cold countries, water in lakes and ponds does not freeze all at once. So only the top layer. So if you take a pond, only the top layer, you have studied this in earlier classes also. So only the top layer freezes. The water in lakes and ponds will have to liberate large quantity of heat to the surrounding before freezing. The layer of ice, if formed on water, it's a poor conductor of heat. So ice is poor conductor. So it prevents further loss of heat. So it does not freeze. The entire water body is not freezing. So the fish can still live. Just a minute, ma. చేరిస్తారమ్మా ఇంటికి మంచిది మా ఓకే మా మంచిది మా మంచిది మా మంచిది ఓకే మా బాయ్. So aquatic life is not frozen to death just because of high specific latent heat of water. So drinks get cooled more quickly by adding pieces of ice. Just now we studied that, right? That is a reasoning question. So this one that I mentioned. Why we have to store cool drinks in ice cubes than ice cold water? That's also because it takes 336 joules energy. Extra heat energy can be absorbed by ice cubes. Okay. B part is simple. No numericals. Only graph question. When ice is frozen in frozen lake starts ice in frozen lake starts melting, surrounding becomes very cold. What is the reason? Because extra 336 is released. Large amount of heat energy is released. Sorry, lot of heat energy is absorbed from the atmosphere. So the surrounding gets cooled. It's generally more cold after a hailstorm than during or before hailstorm. That's another reasoning question. The reason is that after hailstorm, ice absorbs heat energy required from the surrounding. So temperature falls further down. So during hailstorm, it is not that cold. During or before, it is not that cold. But after the hailstorm is really cold because extra energy is absorbed from the surroundings. 330 joules per gram. Oh, we do have. Okay. Okay, these are all easy questions. So these are all 4 marker, 3 marker. One should, any question paper you check, there is one calorimetric question of 3 marker or 4 marker. A slab of ice at 0 degrees Celsius is constantly heated till the steam is formed at 100 degrees Celsius. Draw the graph showing the change in temperature with time. This question can be a 1 marker MCQ. They will give you 4 graphs and ask you to choose the right one. So ice is, there is no increase in temperature. It is remaining at 0 degrees Celsius for a while, for 18 seconds here. And then it starts increasing. So this is the water phase. Here it is ice phase. And then after, 30 8 seconds or so, it starts boiling and it is still steam. Maybe when all the water is converted to steam, it will increase 102 degrees, 103 degrees, like that. They may give you the graph and ask you, this is A, B, C, D. What does AB show? What does BC show? What does CD show? This also they can do in one marker MCQ. Are you thorough with the first question, ma?
Yeah, ma'am.
Yeah, auntie.
Okay. Let us look at the second. Let me know, ma, when you have to go. You said 7 o'clock, right? Okay.
Yeah, ma'am.
Yeah.
Okay. A piece of ice is heated at constant rate. So let us look at the temperature. Piece of ice cube is melted. What is represented by part AB? So it can minus 10 to 0. It is still in ice cube. If you say O to A, OA is ice cube. Ice cubes getting heated. From minus 10 to 0 degrees Celsius. Still it is an ice cube form. From A to B, ice melts. Phase change. From B to C, water is heated up. No phase change. From C to D, 0 to 100 degrees Celsius. C to D, boiling, phase change. What conclusion do you draw regarding the nature of ice from the graph? So, melting point is 0 degrees Celsius, boiling point is 100 degrees Celsius. So it is pure ice, no impurities. Ice is initially in solid state at minus 10 degrees Celsius. What is the nature of ice from the graph? It is pure ice, as the melting point and boiling point is 0 degree and 100 degree. And originally it was minus 10 degrees Celsius. That's what we are talking about. The ice initially is in solid state at minus 10 degrees Celsius. Easy to do. This can be, if you get these kind of questions, theory questions, it's very, very easy. So you have to interpret the graph and do the questions. Substance initially in solid state. So we don't know whether it is ice or anything else. It is 0 degrees Celsius in the initial stage and it is heated, and we get the graph. If the specific heat capacity of the solid substance is 500 joule per kilogram per coulomb, find the mass of the substance. So specific heat capacity is 500 joules per kilogram per joule. So L is equal to Q by M. So if it is 1 kilogram, so if M is equal to 1 unit, here we have kilogram, so let's keep it as 1 kilogram. Then L is equal to Q, which is 500 joules per kg per Celsius. Use the graph to find mass of the substance. Okay. Here, the melting happened at happens at B to C, which is 80 degrees Celsius. and heat energy supplied is this is 1000. What is 1000? This is 1000, this is 2000, this is 3000. So I can say 200, 400, 600, 800 is from 800 joules, 1.2, 1.4, 1.6. 1600 joules minus 800 joules is used to melt. So 800 joules is used to melt the substance. So here they are asking what is the mass of the substance. If mass is 1 kg, then latent heat of melting is 500 joules. Now we have supplied 800 joules. So what is the mass? So 500 is equal to 800 by mass. Now cross multiply 500 into m is 800. M is equal to 800 by 500. This is 1.6 kg of the substance. What is the latent heat of fusion of the substance in liquid state? It should be the same if it is pure substance. Okay, sorry, ma. They are doing it in a different way. We are using the first chapter formula. First part formula. Sorry about this. 800 joules is correct. Why not 1.6 joules? Okay. So they're using Q equal to MC delta T. See, we have to use this form only during phase change. So 800 joules, mkg of heat energy absorbed is m into specific heat capacity into rise in temperature. Q equal to mc delta T you studied. So heat energy is 800 joules. From the graph, we know that 800 joules of heat energy is used. That is equal to, we have to calculate mass and specific heat capacity is 500 joules, which is C. So C is 500 and delta T is 80 minus 0. Why 80 minus 0? Look at the temperature change. From B to C, sorry, they are taking A to B. I should not take B to C. In the graph, A to B is 0 to 80 degrees Celsius and the heat energy is 800 joules. Let me just completely cut this off. Substance initially at 0 degrees Celsius, heated, graph is shown. Specific heat capacity, what they have given is C is equal to 500 joules per kg per Kelvin they have given. Kg per Kelvin or kg per Celsius, both are same. So mass of the substance, so we are using the A to B. From A to B, 800 joules of heat energy is absorbed and the temperature is increased from 0 to 80 degree. That's why we are using Q is equal to MC delta T. So 800 is equal to m into 500 into 80. So m is 800 by 500 into 80. This is 10 times. This is 50 times. 1 by 50 kg, which is 0.2 grams. Sorry, 0.02 kilograms. That is the first part. And the second part is the specific latent heat of fusion of the substance in the liquid state. So what is L? Asking. Specific heat capacity is C. Specific latent heat of fusion is L. So look at the B to C graph for L. A to B graph for Q. B to C graph for L. BC represents the change of state from solid to liquid. So 800 joules are absorbed to melt all the substance. So you know that 20 gram of substance is there. It is taking 800 joules to convert the phase. So we can apply the second formula here. Part B formula here. L is equal to Q by M. Formula for B part. Second part. Whenever there is phase change. So heat energy absorbed is 800 from the graph. Mass of the substance is 0.02 from the bit 1. So you can calculate what is the latent heat of fusion. It is 40,000 joules per kilogram. We can even check what kind of object it is from the table. 40,000. It is approximately sulfur. This is 37,700 is sulfur. If they sometimes they give you the table and then ask you what substance could it be. So you can locate the substance. Okay, next question we will do properly. Are you able to follow my third question solved example?
Yeah, ma'am.
If you have any extra question in your textbook, I want to do that also. How much heat energy is required to melt 5 kg of ice? Specific latent heat of ice is 336 joule per gram. Okay, so M is 5 kg. Specific latent heat is L. L is given. So Q is equal to L by M. They are asking what is Q? You know L, you know M. Just substitute and calculate heat energy required. Sorry. Formula reversed. L is equal to Q by M, which means Q is equal to L into M. You know L, you know M. So Q is this many joules of energy is required to melt 5 kg of ice. Direct formula. So we have 10 more minutes. Let's do this question. This is the 3 marker. Temperature of 300 gram of water at 40 degrees Celsius is lowered to 0 degrees Celsius by adding ice to it. So we have a beaker with 300 gram of water and the temperature is 40 degrees Celsius. And they are adding some ice cubes. As soon as the ice cubes are added, the final temperature is 0 degrees Celsius. So they have added m gram of ice, 300 gram of water and m gram of ice is added. and the temperature is 0 degrees Celsius. Find the mass of the ice added if specific heat capacity of water is 4.2. So C is 4.2 joules per gram per Kelvin. Specific latent heat of ice is 336 joules per gram per Kelvin. So we have water is 40 degrees Celsius. So number one, step one, water should cool from 40 degrees Celsius to 0 degrees Celsius. And step two, ice cube melts from 0 degrees Celsius to 0 degrees Celsius. Okay, so 300 gram of water cools from 40 degrees Celsius to 0 degrees Celsius, and m gram of ice melts from 0 degrees Celsius to 0 degrees Celsius. And whatever the temperature, whatever the heat energy released by the ice cube is equal to heat energy absorbed by the water. Released by the water is absorbed by the ice. Let me write. Heat released by water, 300 gram of water, is equal to heat absorbed by m gram of ice cubes. So we are writing mc delta T, this is for water. This is equal to Q into whatever that phase change. Phase change by the ice cubes. Phase change by m gram of ice cubes. Are you able to follow, Ma? We have two substances mixed now. We have 300 grams of water, which is at liquid phase. This gets cooled down because of the ice cubes. Ice cubes absorb heat energy, water releases heat energy, and both of them together reaches 0 degrees Celsius. Two things are happening. Phase change is happening, change of temperature is also happening. So fall in temperature is 40 degrees Celsius or 40 degree Kelvin, because water was 40 degrees Celsius, now it became 0 degrees Celsius. So heat lost by water is mc delta T, or heat lost or released by water. So mc delta T is going to be 300 grams. Since everything is given in grams, we can keep it in grams. 300 into C is 4.2 into delta T is 40. Phase changes m dash L. They have kept it as m dash. No problem. We can keep it as m dash too. M dash gram. So m dash into L is 336 joules. Heat energy released by the water is equal to heat energy absorbed by the ice cubes. So we can calculate m dash is equal to 150 grams. M dash is equal to 300 into 4.2 into 40 divided by 336. This is divisible in 4 table. 8 times 4, 4 times 4, this is 10 times 4. Again divide by 2 table, 42, this is 5. Again you can divide this, or I can convert, or I can convert. 4.2 into 10 is 42. M dash is equal to 300 into 42 by 84. So this becomes 2, this becomes 150. 150 grams of ice cubes is taken. Just by adding the ice cube, it completely melted. Are you able to follow, ma? This is going to be the 3 marker or 4 marker. Okay, ma, I think we can continue. So what time will you reach? What is the earliest you can join?
Like maybe the same time as yesterday.
Yesterday you came only at 5 o'clock.
Uh, yeah. No, I think I came at 5:30. I think.
Oh. Then evening we can do only maths.
Yeah.
Okay, ma. So maybe after your trip is over, we can have weekend classes. Okay, ma. You can go for your